everybody. Welcome back to Succinct Psychology. My name is Prescott, and today we're going to be starting Chapter 5, Sensation and Perception, from the Psychology 2E OpenStax PowerPoint image slideshow. So, without further ado, let's get going. So, first off, we have sensory systems. Our sensory systems are responsible for providing information about our surroundings, which allow us to successfully navigate and interact with our environments. So, for this picture, if you were standing in the midst of this street scene, you would be absorbing and processing numerous pieces of sensory input because there's a whole lot going on there, so your senses would be a little overloaded. So, what is sensation, or what makes up sensation? So, first off, we have sensory receptors, which are specialized neurons that respond to specific types of stimuli. Now, sensation occurs when sensory receptors detect sensory stimuli. When sensory receptors detect a specific stimuli, it's like a tongue twister, I'm going to slip up a lot this unit, they convert that energy into an action potential which is sent to the central nervous system. This is called transduction. So, sensory systems are made up of vision, hearing or audition, smell, olfaction, taste, gustation, touch, somatosensation, balance, vestibular sense, body position, proprioception, movement, kinesthesia, pain, nociception, and temperature, thermoception. And pretty much all of those have ception at the end of them there. So perception, sensation, all that good stuff. So sensation. For a stimulus to cause an action potential, it first has to be strong enough to be detected. Now, an absolute threshold is the minimum amount of stimulus energy that must be present for the stimulus to be detected 50% of the time. So on a clear night, the most sensitive sensory cells in the eye can detect a candle flame 30 miles away, which is crazy to think about. We are also able to receive messages presented below the threshold of consciousness awareness, which are known as subliminal messages. So the stimulus causes an action potential, but we are not consciously aware of it. That's a subliminal message. So next we have a just noticeable difference, or JND. The minimum difference in stimuli required to detect the change or difference between stimuli. So this can change depending on the stimulus intensity. So for example, a cell phone lighting up in a dark movie theater is more likely to be noticed than if it lights up in a brightly lit shopping mall. The brightness of the cell phone does not change, but the ability to detect the change in illumination does. As I'm sure if you've been in a movie theater and somebody's gotten out their phone, you immediately notice it, because it's a dark room with a bright phone going on. But walking around in daylight, you probably aren't going to notice if somebody turns on their phone, because it's the just noticeable difference. The JND would be the minimum increase in brightness required for the change to be detected. Next, we have perception, which is our sensory receptors collect information about our environment, but it is then how we interpret that information that ultimately affects how we interact with the world. So perception is the way that sensory information is interpreted, organized, and consciously experienced. Perception involves two forms of processing. Bottom-up processing, which is a system in which perceptions are built from sensory input. So perception is built from how you sense things like the touch or the taste or the sound of it. And then we have top-down processing, which is interpretation of sensations is influenced by available knowledge, experiences, and thoughts. So here's a nice little chart. So top-down processing occurs when previous experience and expectations are first used to recognize stimuli. And bottom-up occurs when we sense basic features of stimuli and then integrate them. So I can think of top-down, an example would be that you smell a certain smell and it reminds you of a previous experience or previous sensation, and so that's how you recognize the stimuli. You're like, oh, that smells like this, and I know it from my previous experience. And then again, bottom up is just, you sense the basic features of stimuli and then you integrate them into your perception. So, factors affecting perception. So first we have sensory adaptation, and that is not perceiving stimuli that remain relatively constant over prolonged periods of time. For example, when you first enter a quiet room, you may hear the clock ticking. Over time, you become unaware of the ticking. The ticking is still affecting your sensory receptors, but you are no longer perceiving the sound because you've gotten used to it, you've gotten accustomed to it. So then we have attention. So first we have inattentional blindness. So it's failure to notice something that is completely visible because of a lack of attention. So in this picture here, we have nearly 1/3 of participants in a study did not notice that a red cross passed on the screen because their attention was focused on the black or white figures. So when we look at this, this is a still image, so clearly you notice the red cross, but if it was a screen scrolling past you, and for a while it was nothing but black and white figures, you might not notice the red cross because you're focused on the black and white figures, and the red cross is so just not what you're focusing on. It's not the focus of your attention. So next we have factors affecting perception. So we have, well, continuing, not next. But we have motivation. So sometimes we think we hear something, such as a phone ringing, when it is not, because we are motivated to perceive it, such as waiting for an important phone call. Or same thing, you're waiting for a text from somebody. You might be, oh, did my phone just buzz? But it didn't. But that's because the reason you thought it was is because you're motivated to perceive it. You're waiting to hear that phone ring or the vibration. And with that, we have signal detection theory, which is change in stimulus detection as a function of your current mental state. So again, that's that eagerness, your mental state is you really waiting for that phone call or text, and so it changes your stimulus detection. Next, we have beliefs, values, prejudices, and expectations. So people who hold positive attitudes towards low-fat foods are more likely to rate foods with low-fat labels as tasting better than people with less positive attitudes about low-fat products. So that's a nice example of how your beliefs, values, prejudices, and expectations affect your perception. And next, we have life/cultural experiences. So one study found that people from Western cultures, where there is a perceptual context of buildings with straight lines, were more likely to experience certain types of visual illusions, like the Mueller, because it's supposed to have an umlaut, I'm pretty sure, Lear illusion, than individuals from non-Western cultures, where they are more likely to live in round huts. So see the umlaut, that's what I was talking about. But we'll just say Mueller, just to make it easier. So the Mueller-Lear illusion. So in the Mueller-Lear illusion, lines appear to be different lengths, although they are identical. So arrows at the end of lines may make the line on the right appear longer, although the lines are the same length. So right here, because of the direction of the arrows, it's making the right line, because, as long as you're from a Western culture, if you're not, maybe this doesn't affect you. But because of the shape of the arrows, where they're pointing, it's making this line appear longer than this line, even though they're both the same length. And figure B, when applied to a three-dimensional image, the line on the right again may appear longer, although both black lines are the same length. And I don't know about you guys, but it definitely, to me, looks like lines on the right are longer than the ones on the left, but that's the illusion. I'm from a Western culture. I'm used to architecture with straight lines, so that's probably why. So, actually, I don't want this first part to go on too long, but we do have a good number of slides, so I'll finish up with amplitude and wavelength. So, visual and auditory stimuli both occur in the form of waves. So two physical properties of waves are amplitude, right here, and wavelength, shown here. The amplitude, or height, of a wave is measured from the peak to the trough. The wavelength is measured from peak to peak. So amplitude, height, wavelength is the distance between peak to peak. So we will go more into wavelengths, starting with frequency, in the next video. But I hope you guys enjoyed learning about, different types of processing, sensation, perception. We will continue with frequency in the next video. Again, this is Psych Sync, so Sync Psychology. My name is Prescott, and I will hopefully see you guys in the next video. Thank you very much. Bye-bye.